Hello, and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and get ready for that grade A. Hello, welcome back. Great to have you back. Great to have you here if you're a first-time listener. I'm glad you found us. Firstly, I wanted to say thank you to the show's latest patrons. So thank you, Nick Vene, for your support and for your kind words too. And thank you, Jesse Springer. I'm looking forward to answering your chemistry questions as we go through these episodes too. If you want to be like Nick or Jesse, there's a support link in the show notes, and that link takes you to our Patreon support page where you can sign up. And now, on with today's topic. In this episode, we're going to clarify a couple of terms in organic chemistry and talk about what they mean, because they're going to be really quite important as we start to look at the different types of organic compounds that exist. The phrases we're going to look at are functional group and homologous series. So what is a functional group? In the previous episode about how we use different formula to show structure, I alluded to the possibility of other elements in organic compounds other than carbon and hydrogen. Where those other elements occur in a molecule is called a functional group. This might be where there's a halogen atom, a chlorine atom, for example, or an alcohol, an OH group, and there's all sorts of other examples as well. Even the presence of a double bond between two carbon atoms rather than the more common single bond is considered a functional group too. Why is it called functional? Well, it's because all of these examples make the molecule more reactive, make it reactive at the position where that functional group exists. And when you considered it in the episode where we introduced organic chemistry, I was talking about the stability of carbon to carbon and carbon to hydrogen bonds, how strong they are and how stable they make organic molecule structures. Then it stands to reason that changing that putting a double bond in, or substituting a hydrogen for a different functional group increases the reactivity of that molecule at that point, because in virtually every case, that is going to be a more reactive position. There's likely to be more polarity and weaker bonds, both of which increase the reactivity of the molecule at that position. And these functional groups result in us having families of compounds. And these families of compounds have names which indicate which functional group is present in them. You may have heard of alkanes. So alkanes are the most simple organic compounds. They're the compounds that only have carbon and hydrogen, and they only have single bonds. So all the carbon to carbon bonds are single bonds, all the carbon to hydrogen bonds are single bonds. So in effect, there is no functional group present in those. I mentioned earlier that having a double bond between two carbons is considered a functional group, and the family of organic molecules that has double bonds between two carbon atoms is called the alkenes. Another I mentioned was when a hydrogen atom is substituted with a halogen atom. These are the halogenoalkanes. In a halogenoalkane, you'll have a bond between a carbon and, of course, either a fluorine, chlorine, bromine or iodine atom rather than a bond to a hydrogen atom. So the halogen atom has substituted for the hydrogen atom. Another group that could be substituted for a hydrogen atom is the OH group, and that gives us alcohols. Alcohols all have an OH group, and in this group, the carbon is single bonded to the oxygen atom, and the oxygen atom is also bonded to a hydrogen atom too. So we have an OH group. Oxygen can come into organic compounds in other ways too. Oxygen needs to make two bonds, and it can make both of those bonds with a carbon atom. So if we have a carbon to oxygen double bond, when that's on a mid-carbon within a carbon chain, we call those compounds ketones. Where it's on the end carbon in a carbon chain, we call that family of compounds aldehydes. And then we have the carboxylic acids, where an end carbon in the molecule has a double bond to an oxygen and separately a single bond to an OH group. There's many more functional groups as well, and you'll need to know these ones and a few more for your chemistry studies at this level. Now, the other phrase we were going to talk about was homologous series. Homologous series refers to any one of those individual families of compounds we just talked about. If we talk about the alcohols, we use the example ethanol. Well, ethanol has two carbons in the carbon chain. the formula is C2H5OH, so the OH group is on one of the N carbons. There is also an alcohol compound that only has one carbon. Its formula is CH3OH, and it's called methanol. Now, the difference between methanol and ethanol is just that the chain length increases by an extra carbon with its associated single bonds to hydrogen. We go from CH3OH to C2H5OH. And if you do the math there, that's increased by one carbon and two hydrogens. And that generally is the increase from one member of a homologous series to the next. If we think about the next alcohol in the homologous series, the one with three carbons, that's propanol. And that has the formula C3H7OH. Again, we've increased by one carbon and two hydrogens. And that would continue as the chain length of the molecule within the homologous series increases. From one to the next, it increases by CH2. How about for other family, for halogenoalkanes or for the aldehydes, for example? Are exactly the same. As we increase the chain length by one carbon, we're actually increasing the formula by CH2. There is an extra carbon and two hydrogens as we go from one to the next. So let's have a quick summary of what we've talked about today. We talked about functional groups being part of a molecule that is not just a single carbon to carbon bond or a single carbon to hydrogen bond. There is a different element present, or there is a double bond between carbons present. And that functional group is so called because it's increasing functionality, it's increasing the reactivity of that molecule, and the functional group is also dominating and defining the chemical properties of that family of compounds. And we also talked about homologous series. So this would be the different molecules within a family that have the same functional group but have different carbon chain length. And we gave the example of the alcohols with methanol, ethanol, propanol, and that's an endless list. You could carry on and on. But the difference being between one and the next, as we increase the chain length by one carbon, we're increasing by not just one carbon, but two hydrogens. And that's always the case as we increase the chain length by one in any homologous series. That's the end of what I wanted to talk about in this episode. This is just the third in the series on organic chemistry. There's so much more on organic chemistry. There'll be a lot more episodes coming up. So do make sure you're subscribed and do keep listening to this series of episodes on organic chemistry. I'm really looking forward to talking to you in the next episode about the next topic in the series. Until then, do look after yourself and goodbye. Maybe what we've talked about today has sparked some questions, or you had some questions on this topic anyway, and you're still looking for an answer. Well, I go deeper and answer more questions for the show's patrons after each episode now. And you can become a patron very easily and for about what you'd pay for a coffee. You can find out more by going to patreon.com/chemistrymadesimple. That's patreon.com/chemistrymadesimple. And that link is in the show notes too. Once you're a patron, you'll find that I invite questions after each episode, so you're not left wondering. So I'll see you in that Patreon membership soon. Go there now.